Hey everyone, I'm Greg from ENS, and today we're going to be talking about all things ENS. So first of all, raise your hand if you have an ENS name. Okay, a good portion of the room. Does it what? Sure, testnet counts. This is a hackathon. Cool, so today we're going to be running through a bunch of things related to ENS. First of all, what is it? Why is it important? What are the different types of ENS names? Clear up some misconceptions there. How does it work under the hood? And so on. So let's dive into it. What is ENS? ENS is a decentralized, permissionless naming protocol that lives on Ethereum, but is built to scale to the entire internet. So DNS solves a problem of IP addresses to website domains in the real world, which we all use and depend on today. ENS solves a similar but harder problem for crypto. Ethereum addresses, for example, are much worse to remember than IP addresses. That's just not going to happen. And so ENS is human-readable names for crypto addresses, starting with Ethereum. So the idea is anywhere you read or write an Ethereum address, or really any crypto address, you should be able to use a name instead. And that's exactly what ENS allows you to do. So here you can see I have luke.eth, the guy over there, sending something to gregsgrill.eth, or you have myself sending something out to a random address. And if you ask me, a name to a name is just a more enjoyable user experience for everybody involved than a name to an address or an address to a name. You never know really what's going on chain. So an example of using this out in the wild would be something like MetaMask or any wallet. Instead of sending assets to a copy and pasted hex address, a long 42-character string that, again, nobody's going to remember and really has no personality tied to it, I could just send something to gregsgrill.eth, my ENS name, and my on-chain identity, and it just works. And ENS started as this idea of a Web3 username, right? Instead of typing an address, you would type in a username. But over time, it's really become this profile, so you can attach more data to a name than just the name and address itself. And the way that works is through this thing called reverse resolution, or your primary name. So by default, when you register a name, the name points to an address, right? But anybody can have infinite number of names, or I can register a name that points to one of your addresses. And so how do we know what name the address owner actually wants to associate with? And the answer is reverse resolution. So a user goes ahead and sets their primary name, basically saying, I want this address that I control, or this contract, or anything like that, some entity on-chain to be recognized as this ENS name, again, the on-chain portable identity. And when I set that primary name, or when I kind of configure reverse resolution, oh, it's glitching a little bit, but I am then recognized as this profile across Web3. So I log into different types of websites, and I'm always just recognized as, again, this portable Web3 profile, which is powered by ENS. And here's another view of that profile, right? It's not just a name and an address, like you might see here and here, if you can see my cursor. It also includes data such as a description, a web URL, my social media profiles, and so on. And this is really getting to the idea, again, of a profile rather than just a username. And so you can see all these websites on the bottom have pages dedicated to my on-chain profile recognized by an ENS name. And again, this is the portable global Web3 profile that just works across the ecosystem, all powered by ENS. So you might have an idea of why it's important, right? But ENS is a lot of things. It's fun, it's cool, it supports multiple chains, it's a public good, it's decentralized, but ultimately it improves the crypto user experience. So if you take the Ethereum logo here in the top right corner, you'll notice that the ENS logo is just a nice friendly wrapper on top of the Ethereum logo. And that is because ENS is a nice friendly user experience wrapper on top of the Ethereum ecosystem, and really the crypto ecosystem as a whole. So I always like to point out the logo really embodies the ethos of ENS and of Ethereum. So down to some misconceptions. What are the different types of ENS names? Most people think ENS is just .eth names, and that is certainly a big part of it, but also not the entire picture. So you can use any DNS name, or most DNS names, within ENS the protocol, and so that is a .com, .xyz, and so on. And I'll get into exactly how that works in a second. So the differences between these two are definitely worth noting. You know, most of the end user functionality is similar, but technically there are some differences. So .eth is Ethereum native. It lives on mainnet Ethereum. It is fully decentralized, operated by smart contracts that are owned by the ENS DAO. And so the only way that these contracts change are by a community vote, basically, from ENS DAO. There's no single person, there's no single team that can change anything related to .eth as it exists as an on-chain identifier. And this makes it different than basically all other blockchain names or just all other internet names. And to make sure that .eth stays as a healthy namespace, there is an annual protocol fee, usually of $5, to prevent kind of unhealthy usage of the namespace. You'll notice that in a second, this is different than other types of ENS names. So .eth is the top dog of ENS, the most decentralized, the most on-chain, I guess you could say, and it's just the top dog in ENS. But if you have an existing DNS name, which I would guess most people in this room also have, you can use that in ENS as well. So with a DNS name, using it in ENS, there is no protocol. There's no protocol fee on the ENS side, so it's completely free, except we've had this problem of very high gas costs to import a name. And that's just because of the way submitting the proof works and all that stuff. But soon, this is going to be possible completely for free using what I'm going to talk about in the next slide. So off-chain ENS names are something that most people don't quite wrap their head around the first time they hear it. So I'm going to try and dive into it and explain exactly where it's coming into play and how it's working. But off-chain ENS names are ENS names that work similar to most others. You could type it in MetaMask, you could look up a wallet address on Etherscan, and so on. But as the name implies, they're off-chain. So there's no protocol fee. It gives developers the ultimate flexibility because they can store name data anywhere they want, whether that's a database, a static JSON file, a layer 2, and so on. And it's made possible by this cool standard called CCIP read, or EIP 3668. It allows smart contracts, it defines a custom error for smart contracts to throw that allows clients like front ends to securely retrieve off-chain data. And that data kind of points to what a name, points to an address that a name wants to resolve to, or any other type of data relating to a name. So this off-chain technology, CCIP read, within ENS is already used across the board quite a bit by Coinbase, Lens, Eco, really big crypto teams, and so it's widely supported across the board, and I think something that we're seeing more and more people build on, so might be something exciting for you to play around with this weekend. And I want to give an example of what exactly that could look like. And I might be slow to type with one hand, but we'll check it out. If I go here. Cool. So this is an example that I have set up, which will allow me to basically register an off-chain ENS name. And otherwise, that means sign a message and insert a record into a database. Right? This could be any Web2 database in my case. So I'm going to go ahead and make ETHRome.offchaindemo.eth. Offchaindemo.eth is an on-chain ENS name, and it set a certain record that allows me to do this flexible stuff. And I'll get into what that means in a second. So I'm going to register ETHRome.offchaindemo.eth, and you can see that's making an off-chain signature, totally free, no gas, no fee, no nothing. And now this is a working ENS name. If I go to the ENS Manager app and show you ETHRome.offchaindemo.eth, you'll see that it resolves to an address, and it's a subname of offchaindemo.eth. And just to prove to you that this actually works and is not like some ENS app thing, I can go into MetaMask, which is an independently run application, obviously. I can type in the name ETHRome.offchaindemo.eth, and it just works. It resolves to this address. I could send it ETH. I could transfer NFTs. I can do anything. And this is all off-chain, all free for the user, and powered by CCIP read. So this is a cool way to give your users an ENS name, or name their Ethereum accounts, basically, if they don't already have an on-chain.eth name. And again, it's free. So you could see some pros and cons here compared to on-chain ENS names. But if you want to give that a try yourself, or see the code behind how that works and some docs, I'll leave this QR code up here for a second. That links to the page, which then on that page links to some more docs and the code. Cool. So how does ENS work, and then how does this off-chain stuff work by example? So ENS is powered by this core registry. A registry is just a smart contract on Ethereum, and it keeps a list of all ENS names, or rather all on-chain ENS names. And so it's formatted kind of like this. It's a simplified version, but good enough for the sake of a demo. So I have a name, gregscroll.eth, my ENS name, and I have a resolver. A resolver is a smart contract which stores all the data associated with an ENS name. So you'll notice here that another ENS name, like rickmood.eth, could exist and use the same resolver. So one resolver can be used by multiple names, but also there can be specialty resolvers. Anybody could go build a spec-compliant resolver, and it can do kind of whatever you want. And you'll notice that Off-Chain Demo has a special resolver that we'll go through in a second, does some cool stuff. And if we look into how these resolvers actually work, there are basically a few types of lookups for a name. And again, this is a simplification, but should be clear enough for a demo. And so I have a name, and for a name, I can store addresses and I can store text records, right, and some more stuff. But addresses and text records are kind of the most popular use case, and what I wanted to highlight here. So within an address record, you can store any different chain. You can store an address for any different type of chain. So that's another misconception with ENS stuff, that it's just for mainnet Ethereum. But you can see here that rickmood.eth has an Ethereum address stored and a Bitcoin address stored. And so if a wallet supported both mainnet Ethereum and Bitcoin, like something like Coinbase Wallet, for example, you could send Bitcoin to rickmood.eth in Coinbase Wallet. And I think that's something that most people don't fully realize, and is pretty cool the first time you wrap your head around how that works. And similarly, text records allow for any type of text, right? So it's any arbitrary key value pair. You'll see here that rickmood stores com.twitter as like a social record. He also stores an avatar record. But for the sake of a governance and privacy hackathon, maybe you store some encryption key here. Maybe you store some other identifier of a person about their ENS name or of an account. And so the idea is that text records, addresses can be as flexible as you guys would like. And so one of the prizes is inspiring people to get creative with text records, but I'll touch on that in a little bit. So that was an on-chain resolver, and now this is what an off-chain resolver could look like. And this is what the off-chain resolver for off-chain demo.eth looks like. So instead of looking at basically internal contract storage to see what ETH address the name will resolve to, or what the com.twitter text record will point to, it reverts with this off-chain lookup. And this off-chain lookup basically follows the CCIP read spec that I was talking about before. So when a library like Ethers or VM gets to this contract and sees the off-chain lookup, then it will know to go look off-chain at whatever data source the contract provides, and that is the resolver contract, and it will retrieve that data from a database, from a layer 2, and so on, like I described before. So the off-chain demo.eth demo, what I was doing before, is storing a record in a database, and then when the client gets to this point in the contract, they'll go look at that database and get the data for the name, verify it, and then return it to the client. So that's basically what MetaMask and the ENS app were doing under the hood. So with this comes ENS subnames, which we have a workshop to get in more detail tomorrow at 12:10. But basically, ENS subnames are something like sub.name.eth, which are almost as flexible as normal names themselves, similar to gregscroll.eth, but you can do some cool dynamic things with them that I think a lot of people also don't fully understand. So if that piques your interest, then we will be back tomorrow for more info. So this brings me to how are people using these ENS names? And maybe you have some ideas, maybe some of it is straightforward, but just wanted to highlight a few things. So first of all, really just identity, right? If I meet someone at a conference, usually they'll recognize me as gregscroll.eth at this point, just not Greg. And it's this idea that, again, ENS is your portable Web3 identity, and it carries with you everywhere. That includes not just the name, but also the entire profile. So this is another view of those text records that I was describing before. You'll see I have a range of them set. And again, you can store any arbitrary data in these records. Next is, I guess, a similar note of just giving wallet addresses a personality. So Ethereum accounts by default, if one votes in a governance proposal, like you see here on the right, if this was just a list of addresses, it would be really hard to know what's happening, I guess. And having a name on your account really allows it so that users can understand what's going on and get a better view of what's happening on chain. So again, this weekend, if you're building some sort of voting application or anything in the governance side of things, encouraging that your users have an ENS name, or even just showing it if they already have one, or maybe allowing them to register one in the app, either on-chain or off-chain, could be some ideas to play around with, with the end goal being something like this, a user experience where there are names and avatars and personalities attached to on-chain activity. Next would be something that I think is kind of underexplored, and it's this idea of immutable text records. So Uniswap.eth is owned by the Uniswap DAO, and the Uniswap DAO made a proposal to kind of establish this v3 deployments.uniswap.eth. And it doesn't resolve to an address. It doesn't work, I guess, the way you would expect most ENS names to work, but it stores a list of DAO official contracts, or official Uniswap contracts that are like approved by the DAO across different chains. And this is one of the few use cases that I've seen that was like not super obvious to me, I guess, at first, but something that makes a ton of sense. And if you were a Uniswap user and you wanted to see official Uniswap DAO endorsed contracts, rather than just contracts that are deployed by a single person on like a centralized team, then this is where you can go to verify that. So I think it leans into the idea that text records can store any arbitrary data, and when that data is controlled by something like a DAO, it really gets that seal of approval. Next would be usernames on any sort of decentralized protocol. So Farcaster is a decentralized social protocol, and they allow you to use your ENS name as your username. And this means you can post from an ENS name, you can tag an ENS name. It's just a username, right? And again, this leans into the idea that ENS is a portable global Web3 profile. And similarly, we have messaging here. I guess this one's maybe more simple. Would you rather message a random hexadecimal string, or would you rather message a name? I think, again, this idea of a portable Web3 profile shows its value here, all powered by ENS. And you can see Base Cafe, they used a subdomain, so it works similarly there. Cool. Now that we have an idea of hopefully what is ENS, why it's important, how are people using it, maybe some ideas for you guys to use it, I want to highlight some resources we have to get you started. And the next few slides will have a QR code, so if you are looking to get to the next step and start building on ENS this weekend, feel free to scan it as I go through, or obviously we have this info at the booth as well. But we have a front-end quick start guide, which is, I think, the easiest way to get started with a Web3 application. Specific to ENS or not, this is just like laying the groundwork that you'll need to probably build most things this weekend. If you want to get started super quickly, then I would recommend checking this out. There's a GitHub repo template that's also in there, so you can literally get your project started in one click, or a document that runs through everything. We have a design system and a React component library that will allow you to build good-looking front ends faster and easier, which I know is sometimes a hard thing for people at hackathons. So I personally enjoy this when I'm hacking at a hackathon, and I encourage you guys to check that out as well. And this is actually used in the front-end starter template that I just highlighted. And then lastly, we have ENS.js. So popular libraries like Ethers, VM, WAGMI have pretty good support for basic ENS stuff if you were to just resolve a name or check for somebody's primary name or stuff like that. But if you want to get more into the weeds or do cool stuff on the back end or register names, ENS.js is probably the easiest way to do that. It just has a bunch of helper functions. It extends VM, which is a great base layer, and yeah, it makes it easier to do cool things with ENS. So I will leave this one up for a second as well in case anybody wants to scan. But cool. So I have some coding examples that basically use these three tools, which I only have one hand for, so I'm just going to scroll through existing code rather than write anything new right now. But just to show you how simple some of this stuff could be, I'm going to open this, and I'll make it bigger in a second. Oops. Okay, cool. So this is what that front-end starter template looks like, more or less. And it installs Thorin, which gives you these nice cards and fonts and buttons, and it also has a few functional examples of using ENS. I would say a common one is just when you're sending something. Many hackathon projects have this flow somewhere in it where maybe you mint an NFT and you want to send it to somebody, or any sort of sender flow. An easy win is to support ENS in these different flows. So right here, I could enter an address, but I could also enter an ENS name, and it shows the address that it resolves to. So this is very simple. The code for this is like extremely minimal, literally just this. And the ENS part here is just basically 3 lines. WAGME exposes a nice use ENS address hook, and they also have use ENS name and use ENS avatar and so on. And it just makes it extremely easy to get started with ENS stuff. And again, this is the front-end starter template that we have on GitHub and our docs. And also, this is the ENS.js. This is how easy it could be to use ENS.js for a few different things. So one is to get more information related to a profile. So like I said, by default, most times you're like sending something to an address, it would just resolve the address itself that's stored with a name. But you can store these text records, you can store any number of things alongside an ENS name. And ENS.js makes it easier to do exactly that. So you can check all the records that are stored for a given name, and then you can do a call to get all of those in one RPC request. So it saves your users time and you money in terms of RPC requests. So it's kind of like a win-win. And you'll see if I run this, oops. Then this few lines of code spits out all the data related to an ENS name. The resolver address, which I was explaining before, the resolver is what stores the name, the smart contract that stores the data for a name. It stores all the text records that I have stored under this given name and the addresses that it points to. You'll see here this is an array because, again, you can store any type of blockchain address for an ENS name, not just an Ethereum address. So you'll see this one only has an Ethereum address stored, but if it had more, then it would return those in the array as well. And then the other thing I'll show, which if people try to integrate into their app, sometimes have more difficulty with, is registering a name. And so now we have a much more straightforward example of how to register an ENS name, because ENS.js abstracts the more tricky parts. And so you'll see here, this is all just VM setup. And then when we get to registering a name, you can check if the name is available by just calling get available, right? No importing contract addresses and ABIs and figuring out the functions and the formatting and hashing and all that stuff. Takes care of everything for you. Registering a name is a few steps, and it does that right here, commit name and register name. Everything is as straightforward as possible. And so if I run this, actually, let's see if I can register a name on the spot. And we'll see what happens. But, well, yeah, okay, we'll see what happens. But basically, the code is fairly simple to register an ENS name, and you no longer have to dive through any huge hoops to do something like that. Cool. So as that is loading, I want to go over our prizes. Sorry for the quick dark to light switch. We have 5 prizes this weekend. 2 times $1,000 for the best use of subnames. That could be on-chain names, it could be off-chain names, it could be any type of subname. We have 2 times $1,000 for the best use of text records. Again, this could be any data associated with an on-chain profile, whether it's just a cool string, a social account, or some encryption key if you're going the privacy route. You can get as creative as you'd like. And then we also have a $1,000 pool prize to any public good that integrates ENS. And so if you're building pretty much any project that's going to be open source and helpful for a range of people, if you integrate ENS, even using something like WAGME, just a few lines of code, then you could get involved in this $1,000 pool prize. So that is kind of what I have for you today. And in our 5 minutes left, I'm happy to take any questions if you guys have. Okay, if no questions, then that's all good. Thanks, guys.